In this video, we're going to look at a variety of ways that we can utilize to find the distance and midpoints between various endpoints of segments. And what we're going to do is we're going to start out by thinking about something you guys are really familiar with, because as always, everything in geometry comes back to those lovely right triangles. So let's say that I had a right triangle. This right triangle had a side of 6 and a side of 8. Really, what I want to be thinking about is I want to know the distance between these two endpoints. What is the length of the hypotenuse? That's totally next. So, if you recall back in the day, there was a fun little formula that you guys knew about, and it was a squared plus b squared equals c squared, the Pythagorean Theorem, where a and b were the two legs and c was the hypotenuse. So we're going to utilize that to find the distance between those 2 points, or find the length of the hypotenuse. That would be the distance between those 2 points. Alright, so let's do this. So we have 6 squared plus 8 squared, and that equals c squared. So 6 squared is 36, and 64, which is c squared. So 100 equals c squared. And keep in mind we want to find c, so we're going to have to take the square root of both sides. So we can say that c is 10 by the symmetrical property of equality. So that means the distance between those 2 points, I'm going to get another color, this distance right here is 10. Now normally when we take the square root of both sides, we use the positive and the negative case, but since we're not going to have a negative distance, we're good, and we can say that the distance between those 2 points, or the hypotenuse of that triangle, is 10. So let's take another look at this same idea, but let's look at it on a coordinate plane. So let's say that we had the point -5, -2, and we had the point 1, 6, say, and we wanted to find the distance between these 2 points. We would need to think about what actually we have going on here. So we have the points -5, -2, and the point 1, 6. So if you look at this, really, you see that you can make a nice little right triangle in here, and then we could just go back and employ the method we used on the first side. We can find the length of each side. So if I go from -5 to 1, that would be 6. And then if I go from -2 to 6, that would be 8. And now we're back with the same triangle we had before. And we can use the Pythagorean Theorem that says that 6 squared plus 8 squared equals c squared. And we would get that the distance was 10. However, let's think about the specific formula that we could use if we didn't feel like drawing a triangle. We want to find the distance, and let's think about the steps we use when we do the Pythagorean Theorem. So we have these 2 points, and we needed to find the distance between the point, we needed to find the distance between the -5 and the 1. So to figure out that, you can think about it in this terms. We did 1 minus -5. After we found that, we got 6, and we squared it, right? Now again, we needed to find the distance between those 2 points. So we can think, okay, well, we had up at the top, that was 6 minus -2, and then we got 8, and we squared it. And then, at the end of the day, we had to take the square root, right, to get the actual distance. So if you're looking at this, we're actually deriving the official distance formula. Officially, the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. You can see how it relates to the points that we were given above. I don't really care which method you use, whether you choose to use the formula or whether you choose just to continue making triangles to find the distance. Either way works, and I kind of am a fan of the triangle method. There's a lot of different things that we can do to look at, a lot of different things we can look at when we're trying to find that. So we're going to test out our newfound distance skills, and I'm also going to show you one other method I have for finding distance that uses tables and reminds me of slopes, so I love it. All right, so let's prove a couple things. Let's determine if segment AB is congruent to segment CD. That means they have the same length, so basically we need to find out if they have the same distance. Now, if we were going to be looking at our segment AB, we see we could make ourselves a little right triangle here if we wanted to. And we could use our Pythagorean theorem to do that. We would end up with 2 squared plus 1, 2, 3, 4, 5 squared equals c squared. Another method, I told you I was going to have another method for you. Another method that you could do is you could make yourself a little table. I like to make tables. And we can write down the ordered pairs. So we have the ordered pair of 0 and, 1, 2, 3. And we have the ordered pair of 5 and 1. And you can go ahead and find the distance this way, or find the changes this way by going, okay, that was 5. That was minus 2. And you can plug them into the Pythagorean theorem as well. You would use that number squared plus that number squared and take the square root of it. Regardless, either way, we are going to end up with the square root of 29 as our c value. And if you want to think about that as a decimal, you can totally do that too. It doesn't really matter. In this case, we're combining, or we're comparing. So that would be approximately 5.8 or 5.39. All right, so that's AD, and let's look at CD now, and let's see if we can't find the distance there. I'm going to start out by thinking about it in terms of the 2 points. I'm going to show you my table method. So we have x and we have y. So if we have CD, C is at the ordered pair -1, 1, and D is at the ordered pair -3, -4. So if we employ this method, I'm going to go from -1 to -3, and that is a change of -2. I'm going to go from 1 to -4, and that is a change of -5. So in order to use the Pythagorean theorem or the distance formula, or however you plan on doing it, we have that's our change in x's, that's our change in y's. So we have -2 squared plus -5 squared. That's going to get us c squared. And we can see from the work that we did before, we're going to end up with the square root of 29. So we can say, yes, they are congruent. Now, on this same picture, we have a couple other ones. So let's test another. Let's see if EF is congruent to GH. Alright, for this one I'm going to use the triangle to start out, just so you guys can see that method too. If I have EF, I'm going to make that triangle there. Looks like I have a change of 3 and a change of 4. So, in order to use the Pythagorean theorem, we're going to do 3 squared plus 4 squared equals c squared. So we're going to get 9 plus 16 equals c squared. Oh, this is one of my favorites. So we get 25 equals c squared. So the distance is 5. Now let's go ahead and check with G and H. G and H looks a little funky because it's like on its side. But we're going to go ahead and make a triangle again. Or again, you can use the table method, or you can use the big fancy table. Looks like this is 4, and that is 3. So I'm going to end up with 3 squared plus 4 squared equals c squared. And again, you can look and see, yeah, we're going to end up with c equals 5. So yes, those two are congruent. So now that we have a few different ways for finding distance, let's go ahead and look at how we can find the midpoint. What lies midway between these two endpoints of a segment. So let's use the point -5, 4, and let's use the point 3, -8. So here we have a nice little line segment, and I want to find the midpoint of that line segment. Well, before I give you some big fancy formula, let's think about what's going on here. we want to find the midpoint. It's got to be halfway in the middle along the line, so you know it's going to be somewhere in there. Well, we're going all the way from the top all the way to the bottom, so we know that it has to be halfway in between up and down. We also are going to go side to side, so we know that it needs to be halfway in between side to side. So that kind of lets you know what we're going to need to do to find the midpoint, provided my drawing is very accurate. What we're going to have to do is we're going to have to find that up and down distance, and we're going to have to find the side to side distance. We're going to have to find halfway in between those two things. Basically what we're doing is we're thinking about the average. So I'm going to make a table because I love to make tables. I had the point -5, and I had the point -5, 4. And then I had 3, -8. Now, if I said we needed to find the whole side-to-side distance. So -5 all the way to 3 was 8. Which means halfway in between is going to be by changing by 4. So if I'm at -5, I'm going to need to go up 4. And that's going to get me -1. Now let's look at our change in our y's, our up and down. We need to find halfway in between the up and down change. If I'm at 4 and I'm going -8, I'm going, down 12. And again, we want to find the midway in between. So we're going to divide that by 2, and we're going to get -6. So I was all the way up there at 4, and I have to go down 6 to get to the halfway mark. If I go down 6, I'm going to be at -2. So we can safely say that our midpoint is the point -1, -2. Let's see. I actually did pretty good on that one. I did terrible on the y's though. So what does this formula look like? How exactly can you find the midpoint? Where am I getting all these crazy things from? So the midpoint, if you think about what we did, to find the x-coordinate of the midpoint, we found the big distance between them, and we divided by 2. Basically what we did was we found the average. So the midpoint formula looks like this. Find the average of the x's, and that's going to give you your x-coordinate of the midpoint. Find the average of the y's, and that's going to give you your y-coordinate of the midpoint. And you can test it with the points that we had going on there. -5 plus 3 over 2 is -1. And 4 plus -8 over 2 is -2. Again, just like with distance, I'm showing you lots of different methods, and you can decide which one you like the best. Alright, so let's actually put our midpoint formula to test, and let's do a couple of examples. Say we have the point -2, -1, and we have the point 4, 2. And we want to find the midpoint of this segment. So if we were going to use the formula, we have -2, -1, and 4, 2. To use the midpoint formula, we'll have to find the average of the x's, -2 plus 4 divided by 2, which is 2 over 2. So the x-coordinate is 1. Now if we were going to find the average of the y's, we would have -1 plus 2 over 2. So we would have 1 over 2. And our y-coordinate would be 1/2. So we could say that the midpoint was 1, 1/2. If we go up and we look at our graph, we see 1, 1/2. Yeah, that's the midpoint, even with my shoddy lines. And again, you can use the table method to do these things too. So I'm going to show you the table method in another example. So let's use the point 4, -6 and the point -4, 2. I'm going to put those on my grid. Again, you don't actually need the grid at this point, but you can certainly use it because it's helpful in visualizing what's going on. That's a horrible line. But you get the gist. And so here I'm going to use the table method. So I'm going to make my table, my XY table. And I know I have the point 4, -6, and I have the point -4, 2. And I want to find what lives in the middle of those two things. So when I go from 4 to negative 4, I go down 8. And if I'm going to find halfway in between that, I need to divide that by 2, which gets me negative 4. So I'm all the way up there at 4, and I'm going to go down 4, which will get me to 0. Now let's look at our y's. I'm going from negative 6 to 2, so I'm going up 8. If we're going to divide that by 2, because we want to find the midpoint, which is halfway in between, when we divide that by 2, we're going to end up with 4, so a change of 4. So I'm at negative 6, and I'm going all the way up 4, and I'll end up at negative 2. So we can say that our midpoint is the point 0, negative 2. If I look at that up on my graph, I have 0, negative 2, and if I would have drawn a nice, pretty segment, that would have worked out really nicely. So again, these are two methods to find the midpoint of a segment. Now, sometimes you don't know the two endpoints. Sometimes you know the endpoint and the midpoint. So now we're going to look at how we can utilize the midpoint formula to find the other endpoint. So let's say I have a segment AB, and I know that A is at the point 2, 2. And I know that the midpoint of this, point M, is 4, negative 3. What I want to do now is find B. What is the point? What are the coordinates of B, the other endpoint? I'm going to look at this on my grid for starters. I have 2, 2, and I know that the midpoint is 4, negative 3. Now, you can do this two different ways. You can do this using this formula, or you can do this using the table method that I showed you. I'm going to start out with using the formula. We know that the formula is the average of the x's, and we only know one of the x's right now. So we know that 2 plus an x that we're missing divided by 2 equals the x coordinate of the midpoint, which is 4. So we can go ahead and use algebra to solve this. So this is going to get us 2 plus x equals 8, and that gets us x equals 6. So we know that the endpoint is 6. Now we can do the same thing with the y's. We have one y, we know that one y is 2, plus the other y divided by 2 is going to get us the y coordinate of the midpoint, which is negative 3. So we're going to use some algebra. We'll end up with 2 plus y equals negative 6. So get y equals negative 8. Now let's look at that on our grid. We have 6, negative 8. And yeah, I can see that that works out really nicely for my segment A, B, with the midpoint M being at the point 4, negative 3. Now let's look at another one, and I'm going to show you how we can use the table method to do this. So let's say we have the line segment LN, and we know that L is located at negative 3, negative 1. We know that the midpoint is located at 0, 1. We want to find the other endpoint, which in this case is N. We want to find the xy coordinates of that. So I'm going to start out by looking at it on my graph. Negative 3, negative 1, and I have the midpoint, which is 0, 1. So we're going to be looking for that other endpoint, N. And this time I'm going to use the table to do it. So if I get my table set up, I have x, I have y, and I have the point negative 3, negative 1, and 0, 1. Well, we know that the midpoint is halfway. So if I travel on the x's, I go from negative 3 to 0, I go up 3. So to get to the other half, or the other endpoint, I'm going to have to go the same distance. So I'm going to also have to go up 3. So in this case, I'm at 0, I go up 3. That means that I'm going to end up at the point 3. Now we'll do the same thing with the y's. I go from negative 1 to 1, and that means I'm going up 2. I have to do the same thing again because I'm traveling that same distance. So I'm going to go up 2 again. So if I'm at 1 and I go up 2, I'm going to end up with 3. So our midpoint is the point, our other endpoint is the point 3, 3. And let's look at that on our grid. 3, 3, woohoo, we're awesome. We can see that if we had Ln, the midpoint of that is clearly the point 0, 1. Now, we don't always care about the midpoint. Sometimes we might want a point that's on a segment that's a different fraction besides 1/2. And so we're going to look at a method for finding that. Really, it's all related to what we did with distance and with midpoint. So let's check. Let's find out the formula for this by looking at a midpoint first. Let's say we have the point -4, 1, and we have the point 8, 7. And we're going to find the midpoint of that segment. So again, we have the point -4, 1, and we have the point 8, 7. Now, we're going to actually think about what we're doing as we find the midpoint. And I'm going to use the table method because it helps highlight what's going on a little bit better. So we have -4, 1, and we have 8, 7. Now, what we did when we used the table method was we said, okay, well, how far do I go? I go 12, and then I divided that by 2 to get the distance, the halfway distance, and in this case it was 6. So I found the whole distance and divided by 2 because I was finding halfway there. Now, if we think about the y's, we find the big distance, the whole distance, which in this case is 6. We divide it by 2 to find what's halfway there, and we would get 3. So we start with our first x, we add the fractional distance, which is 6, and we end up with the point where the midpoint lies. Same thing with the y's. We had the whole distance, we start out at the 1, and then we add in that half distance, which is 3, so we end up with 4. So our midpoint in this case is 2, 4. So to actually generate this formula, if we were wanting to find the coordinates x, y of some other fractional distance or any fractional distance, what we did was we took the first x coordinate and we added the fractional distance between the two x's. And then to find the y coordinate, we took the first y coordinate and we added the fractional distance between the two y's. And that got us our coordinates. So in this case, we would have a 1/2 there because we divided it by 2. However, what's really cool is that with this formula, we don't have to divide it by 2. We could divide it by 3. We could multiply it by 2/3. We could use any fraction we wanted to, and this method would still hold. That's why I like the table a lot, because it's really easy to see what's going on. So to test this formula out, we're going to use the same segment. So we use -4, 1 again, and 8, 7 again. We're going to find other points along this segment that are different fractional distances. So again, we're going to deal with -4, 1, and we're going to deal with 8, 7. Now let's say I wanted to find a point that was 1/3 of the distance between these two. Again, we're going to utilize that formula first. The point that's 1/3 away is going to be the x, the first x, plus 1/3 of the distance between the x's. And then the y coordinate is going to be the first y plus 1/3 of the distance between the y's. I ran out of space. So I'm going to make myself a nice little table to help me see what's going on. I have the x's and the y's. Alright, so we saw that when we went from -4 to 8, that was a change of 12. Now when we did the midpoint, we only needed half of this. But in this case, we're doing 1/3 of the way. So we're going to need to divide that by 3, and that's going to tell us the change that we're going to do. That change is going to be 12 divided by 3, which is 4. We're going to look at the same thing on the y's. When I'm going from 1 to 7, that is 6. And since I want to find 1/3 as opposed to 1/2 as before, I'm going to divide that number by 3, and so I'm going to get 2. That means that I am going to start out at the point -4, and I'm going to add the 1/3 of the distance, which is 4. That'll get me my x coordinate. then I'm going to start out at y, which is 1. I'm going to add a third of that, which is 2, and that'll get me my y coordinate. So negative 4 plus 4 is 0, and 1 plus 2 is 3. So 0, 3 is the point that is 1/3 the distance between the first endpoint and the second endpoint. So if we look at that on our graph, I have 0, 3. Yeah, that looks like it's about 1/3 of the way along. So I ran out of space on the last page, so I went ahead and redid the graph on this one. We're going to look at another fractional distance, but again using those same points, negative 4, 1, and 8, 7. This time, let's go ahead and let's find a point that is 2/3 of the way along that segment. So this means we want to find the fractional distance of 2/3 as opposed to 1/2 or 1/3 like we did earlier. And again, I'm going to use a table because to me that's the easiest way to look at it. So we have negative 4, 1, and we have 8, 7. Now, we know that the full distance is 12, and we want 2/3 of 12. So we're going to have to multiply 12 by 2/3. What that gets us is 8. So that tells me I start at negative 4 and I add in 2/3 of the distance, which is 8. And that'll give me my x-coordinate. Now let's think about the y-coordinate. I go from 1 to 7, which is 6. And if we want to move along our segment 2/3 of the way, we're going to need to use 2/3 of 6. And 2/3 times 6 is 4. So this tells me that for my y-coordinate, I start at the 1 and I'm going to add in 2/3, which is 4. So that's the coordinate of the point that is 2/3 of the way along the line. So let's go ahead and actually find out what that point is. Negative 4 plus 8 is 4, and 1 plus 4 is 5. So that tells me that that is the point that is 2/3 of the way along the segment. Let's check it on our grid. So I have 4, 5. Ooh, I did pretty good. That is the point that is 2/3 along the way. So obviously, you're going to want to do lots and lots of practice on this because really it's just applying it again and again and you'll have these things memorized. But just to sort of recap, I wanted to go over a few things. First off, the distance formula is distance equals the square root of the change in the x's squared plus the change in the y's squared. And remember, this all just comes from the Pythagorean Theorem. So if you'd rather use the Pythagorean Theorem always in your head as you're finding distance, you can do that because secretly you're using the distance formula. Alright, and then we also looked at midpoint. And the midpoint can be found using the formula of the average of the x's and the average of the y's. Also, we can find other fractional distances, and if we wanted to find the coordinates of other fractional distances, we would use the formula, the first x plus a fractional distance and the first y plus the fractional distance. And that's what we did on the last few examples. We looked at finding a fraction of that distance. Now remember that no matter what, doing a nice little table is a very handy way to do things, where you put the first endpoint at the top, the second endpoint at the bottom, and then in between you can put your midpoint or your 1/3 point or whatever, because you're always looking at finding those distances between and then dividing them by the fraction you want to find. So in this video, we looked at distance, we looked at midpoint, and we looked at finding a point that is a fractional distance along a segment given the two endpoints.